This is the video demonstration for the Phase 3 half-yearly progress presentation of the Sony SSUP project and edge-based cyber-physical system for smart polyhouse solar drying of agricultural food products. You are seeing the front view of our university, Amrita Vishwa Vidyapeetham, with Goddess Saraswati's statue symbolizing wisdom, truth, and knowledge. In this demonstration, we present the SME Upahar Foods, where our AgroESP is being deployed for field studies, the new user interface design for the SME with updated features, and the psychrometric analysis carried out to realize optimal drying conditions. Upahar Foods is established in 1.5 acres land in the suburbs of the Coimbatore city with 7 polyhouse units. One of these polyhouses is allotted for our AgroESP experiments. They are employing 10 to 15 men and women employees producing more than 100 food products. Apart from manufacturing unit, they have a packaging and distribution unit too. They employ and support energy efficient and novel technologies for food preparation and processing. We are now having a glimpse of the food production unit and the pre-preparation and processing flow for fryams, one of their signature food products. The batter formula for the fryams is prepared and distributed automatically on the tray above the food grade polish sheet. They are laid in the solar polyhouse manually for drying. Our research associate, Mr. Shibi, is seen here mounting the Sprisons-based end and edge nodes inside one of their polyhouses. The mounted unit is currently being used for data collection and monitoring of the Upahar Foods polyhouse. The user interface developed in the Phase 1 and 2 has been updated and improved to meet the requirements of SME. We have earlier employed a 64x64 image for our AgroESP processing. SME wanted images with wider field of view for remote visual inspection. The new UI provides the live information about the polyhouse 24/7 for 365 days. The dashboard also provides information about the time remaining for the drying process. Linear regression-based prediction of fryams drying time is currently being developed. We provide visual statistics about the temperature and humidity inside the polyhouse dynamically. With respect to querying, to avoid an user needing to know SQL, SparkQL, and Flex queries to retrieve any information about AgroESP, we have developed a unified user-friendly natural language query interface. This natural language query is fed into an LLM large language model, which automatically maps the query into an appropriate format for the 3 databases. These mapped database specific queries are handled by the custom-built information fusion system to automatically fetch appropriate information from different databases. This part of the video demonstrates the retrieval of details related to the image acquisition pipeline from the image processing ontology. The queries demonstrate retrieving information such as the goal of the image acquisition process, the final resolution of the image obtained from the image acquisition pipeline, the number of processes involved in the entire image acquisition pipeline, and metadata of the image obtained from the Sprisons camera. To build a real-time monitoring and control system, we performed multiple experiments. One of the experiments is to identify the relationship between the rate of drying and the psychrometric gap. To determine the rate of drying, we monitored the water level in a plastic tray. The bottom of the tray has been replaced with food-grade plastic to account for the heat conduction from the black limestone surface, since it also contributes to food drying. The water level using an ultrasonic sensor has been tracked to measure the duration of echoes and determine the height of the water column correspondingly. The changes in the speed of the sound and therefore The duration of echoes with changes in the internal temperature have been accounted for in our analysis. The temperature and humidity values are also recorded simultaneously. These data points are collected every 1 minute and aggregated for an interval of 30 minutes to reduce the effects of noise on our analysis. The exhaust fan in our polyhouse shown here acts as the actuator for the polyhouse system. The effect of the actuator on the psychrometric gap is currently being studied.